All right, hello everyone. We're going to kick this off now. My name is Ava Conti, and this is the CppCon 2018 security panel. If that sounds not right, you might want to double check your schedule and make sure you are in the right room. I am joined here by three panelists. We have Matt Miller, we have Patricia Aas, and Matt Butler, and I'm going to let them do a little introduction for themselves.
All right, hi everybody. My name's, as she said, Matt Miller. I work in the Microsoft Security Response Center. So for the past 10 years or so, I've been on the front lines of software security in terms of defense. So people find bugs, report it to Microsoft, and I'm on the engineering team that tries to fix those and figure out how to make things better for the future. So that's me in a nutshell.
My name is Patricia Aas. I'm a programmer. I've been working on browsers or browser-related stuff most of my career. I started off in Opera software, working on the Opera browser, and my last browser was Vivaldi. I also did some browser-related stuff while I was at Cisco. And browsers are a very popular target, so it's been intertwined into my career. Always.
My name is Matthew Butler. I have been working in C++ since about 1990, and most of what I've done over my career has had some form of security involved in it, whether it was in secure environments, writing software that has to survive attacks, or a network software for protecting networks, and that involves military, law enforcement, and other things. So, and I also gave 2 talks at CppCon this year on secure coding best practices Monday. So you can catch those on YouTube if you didn't see them.
So throughout this panel, everyone is welcome to line up at either microphone that we have here. We've got one over there, and please grill us. This is your chance to ask questions, either of the whole panel, of individual people. To get started, though, what got you guys interested in security? Like, what brought you to the field?
So I've been in and around security for a long time. I guess what got me interested was long ago in the late 90s when the internet started to be a thing and IRC started to be a thing. I got introduced to people who are interested in breaking software. And as a consequence of that, kind of emerging out of that hacking culture, that's where I got interested in both software development and the more nefarious side of writing exploits, finding vulnerabilities, and things of that nature. And it just kind of trickled out from there for me.
Okay, and there are like 2 sides to it. On the one side, I've always been very interested or passionate about users' privacy and users' personal information and things around that, which has always been very important to me. But at the same time, like as a programmer, I've always been interested in how things work at a deeper and deeper level, and trying to pull it apart and understand how that works. And that is one of the parts of hacker culture which I really appreciate.
I sort of came into security, I guess, the back way. I didn't really start in security. It wasn't something I wanted to go into, but it was something that I got into just because I worked in so many secure environments where I was writing software that became targets of attacks, and you don't really get a choice at that point, especially when you're dealing with classified information or if you're dealing with evidence. You have to become somebody who understands and appreciates security, because a lot of times there's a lot of nuances involved in it that people at the top of the organizational chart really don't understand. So I came into it just because you either were secure or you were going to get breached. There was not another option for you.
Very cool. So here we're going to jump right into the controversial questions. Since this is a CppCon event, we should be talking about C++. So from a security standpoint, what is your opinion of C++ as a safe language? Either is it or isn't it by some definition? And explain.
Okay, we really are just going to open the covers.
The floodgates.
Despite maybe the best intent, C++ is not a safe language. It is still far too easy, and many people often do, still make a lot of mistakes, even with C++. That being said, I think that the folks working in and around and in this room on trying to make C++ better are doing a good job of trying to push things forward. Like if you look at the C++ core guidelines, great step, moving things in a better direction. But it's one of these things where to write safe code in C++ today, the cognitive load that every developer in this room and around the world has to have to do that and get it always right is too high, right? It's not a secure by default language. It's an opt in and be really careful, and maybe hopefully you'll get it right, but you probably won't language.
He has some good points. But one of the things that I hope, at least now moving forward, is the way that we teach C++ hopefully is going to change. Because the way that we were taught and the way that we programmed in the past, it was a more of a dangerous way to program. So I hope that we get to a point where we are teaching more value-oriented programming, I guess, and more memory-safe programming, where modern C++ is what we teach, not something we get to at the end. And I think that will do a lot to improve how safely you can program. But we also have better tooling now, like the sanitizers and all of the compilers, and it is not the same as it was 10 years ago.
Yeah, so when I started, C++ was sort of the Wild West of languages. You had this massive amounts of power, but you also had the ability to inflict heavy damage on your systems if you didn't do things correctly. So is it a safe language? I think it's a safe language from the standpoint that it's well documented, and that if you are a lawyer and can read the standard, you'll know exactly where all the sharp edges are. The concern I really have is the last time I went through there was something on the order of 300 mentions of undefined something in the standard, which is a horrifying level of undefined behavior in a language. And when I give talks and I say, what happens, for example, if you pop off an empty vector? There's the blank stare. Everybody's like, I don't know. Well, that's undefined behavior. But most people, I think our problem is how we use the language, because I tend not to want to blame the tool. It's more the person who's wielding the tool, and because we're the ones who can actually change how we use that. So is it a safe language? No, it's a very powerful language. And when you have a very powerful language, you can do a lot of damage or a lot of good. So one thing I'd like to see is, I think, more education around what are the patterns for the bugs that we put into that make us insecure.
I have one thing to add. So I think one maybe challenge or alternate perspective to put out there is, there is always this notion around let's help educate people and eventually help them understand the rules so that they can write safer code, and give them the tools to do that, to find the bugs and everything like that. But, maybe a challenge to think about and to push both C++ and other languages forward is, how do we construct the language and the use of the language in such a way that it's secure by default, right? So that you don't have to memorize the 600, 1,000 different rules to get things right, that you have either through your development tools or just through the language specification, the standard. It's very hard for you to get it wrong. And if you get it wrong, you've really gone out of your way to get it wrong, right? So another way to look at it.
I think maybe that ship has sailed. We have it's not like we can remove 90% of the language. But also I also feel, and this is controversial in almost any kind of context, but I don't believe that every programming language is applicable to every problem. So you don't need C++ to do everything. Like, you use JavaScript to make web stuff, use Python to make your tools, use Java or Go to do your backends. Programming languages are applicable for different things.
So one of the things that I think the standard committee could do that would be a big help is go back through, and SG12 I think has that task, is to go back through, and when we're adding to the language or when we're altering the language with each iteration, is go back and look at where can we remove the undefined behavior and begin defining what that behavior is. A lot of the things that I see, the mistakes I see developers make, the mistakes I made when I was first learning how to do this are, it's actually not the fault of the language. I'm making very simple mistakes. Like I'm not validating and verifying. I'm not verifying who I'm talking to. And you can have that in any language. I do a lot of JavaScript work, so you can have that exact same problem even in JavaScript. I'm not verifying who's talking to me. I'm not validating the data. To me, that's not a language problem. That's my problem, that I'm not making sure that that I know where that data came from and what it is before I start operating on it.
Okay, and I do kind of want to go back to calling out the committee on stuff that they can do to help, but we do have a question from the audience. Gaspar, go ahead, buddy.
So, of course, there's always like the two-pronged approach to security, right? The first one is, if you don't want fires, legislate fireproof like couches, right? That's number one. The second one, of course, is also pay firemen, right? And then make all of the traffic rules that lets them get to the fire quickly and safely and hopefully without endangering the rest of the population and so on. Like there's an enormous amount of infrastructure more on the fast response than on the slow prevention side. And so I was wondering, how do you structure like your deployment paths and your organization and your communication paths in order to facilitate this fast response? Because this is the hard part. And I'm wondering what kind of wisdom you have to bring to this. Like, what should you do when you are structuring your fast response strategy?
Okay, well, he has a big organization, and I come from much smaller kind of scope. So, are you thinking big or small?
I'm thinking more small, but I think both small and big are valuable for this.
Okay, well, he can talk about big, and I can talk about small afterwards.
You start first. Go ahead.
Okay. Okay. Well, because if you're in a small organization, you're more like do it yourself, right? You don't have dedicated people that can do this 24/7. That everybody has another job. So you have to structure more like communication channels. So, for example, let's say that you use Slack. Then you have a special Slack room with people who have this as a dedicated side duty, and everything that occurs there is like an immediate alert, right? And everybody kind of joins in and sees what happened. You also have specialized tagging for your bug reports that come in, so you can mark them as security, and then you have a special priority for that. So security is above everything else, right? And then you can bring it into your peer review process, that you have like a special security comments section that people could look at, just not the code or whatever, but looking at how are you dealing with the inputs? Do we need to deal with something in our infrastructure around this? So it's more about like inserting like little pieces here and there, but also having it being a dedicated side duty for a group of people, because you don't want like one person to be the only person and then they go on vacation or quit or something. So you need to have like a kind of community around it.
Yeah, so I think the question you're asking, I think it's a big question. It's a great question. It's more around security response, right? And how do you respond if somebody finds a vulnerability in your software? Is that kind of the notion?
Yes. I mean, especially for you, like you have to get it to your customers in a timely manner.
Correct. Yeah.
Some of them might not be connected to the internet.
Right. Yeah. So those are maybe some more different challenges. I'll give you maybe the more general answer of maybe the important pieces that you want to have in place to support, rapid security response in the case of a vulnerability. For anybody out there who's working on a product or a service or an offering to a customer, first and foremost, have a place where they can find you to tell you about bugs. That's the most important, because otherwise you may not find out about them, and they won't know where to report if they find them. Once you get the bugs or the vulnerabilities in your door, it's about having that process and understanding about who's on point to drive this end to end, who's on point to drive the pizza making process from, okay, they reported a bug, we reproduced it, we confirmed the severity of the issue, we know who to work with within our company to actually go and remediate that through a fix. And then we have the processes in place to get it into the next release train to go out to our customers, whether that be through a security update like for Microsoft, every second Tuesday of every month, there, same day, same time, there's your security updates. Or some other process, depending on what software you're making. So a lot of it comes down to process and just getting a lot of maturity around that, and trying to work as diligently as you can to responsibly, control for getting that fix out to customers as quickly as reasonably possible, right? Because you do want to protect customers at the end of the day.
I had a talk about this on Tuesday.
It was
Just
really
kidding.
good.
Well, yeah, I did actually. But yes, and I have a single slide dedicated to you have to have some kind of security hotline. But I think a lot of the work is work that you can justify in your normal day to day. You have to have a way to build. You have to have continuous deployment. You have to have automatic tests, because if you have to release on a really short schedule, you can't wait to have like maturity testing and God knows what for months, right? So you have to have good branch handling. And if you have a continuous deployment, this will be much easier. But if you don't, you still have to have a process around doing rapid releases. So it's all of those things that you kind of need to do anyway. But if you get that maturity in your organizations around building and delivering software, then you use that same mechanism to do these fast responses.
So the other half of that is on us. One of the problems we keep seeing in the industry of companies that get breached is they don't patch their systems. When I want to go and attack a system, the first thing I'll want to find is, are you using Apache Struts, and Linux? Okay, you have a Linux web server. I'm going to go out and I'm going to find out what vulnerabilities have been reported and are now exploitable in the wild. And almost every time I can find an unpatched vulnerability that allows me to go into the system. So, and I completely agree with everything they said. I'm on the other side of more the defense than I am on the production side, because the things that I've typically produced are things we control the update cycle for. I know we all complain about, well, Microsoft, they dropped an update, it's got to reboot, it's in the middle of it, I had something running at night, we get ticked off at Microsoft, but they're not dropping stuff out there just because, to be a problem for us. They're dropping stuff out there because they're fixing legitimate bugs that either they know are in the wild or that Matt has found, and it needs to be fixed, because if it isn't, somebody can penetrate your system. So we tend to have a lot of problems with, like Equifax is a perfect example. The struts defect was out there for a couple of months, and it would be another 2 or 3 months after that they finally patched it, even after they had been breached. So we as a community and the people who use the software need to be open to the fact that we're going to need to push updates out to your system in order to fix these vulnerabilities.
Okay. I have one point in that that I talked about in my other talk. Awesome. And that is that in other languages, especially JavaScript has gotten a long way here, but also Java is getting there. They have dependency analysis tools which create dependency graphs throughout and also map those same dependency versions to vulnerability databases. And so if you can make a tool that has continuous analysis built into your continuous integration pipeline that analyzes your dependency versions and maps those to, is this a vulnerable version, and then can alert you on that. Tools like that would be immensely useful. And GitHub has integrated tools like that where you will get a warning on, okay, this version has an actual vulnerability currently, and you should update to X version. And we haven't been really good at around, build systems, dependency stuff, and we have some work to do there, but I also think that we should accelerate that work because it has important security implications.
And we have another question from the audience here. Nice gentleman whose name tag is too far away for me to read. Nick. Hi, Nick.
Hi. So I have sort of an open-ended follow-up discussion item from a conversation I had with a few vendors at Black Hat this year, specifically around dependencies, to sort of dovetail from that a little bit. As developers, we obviously consume a lot of libraries. As end users, we consume products. And there are a lot of guidelines out there, like the style guide and other guidelines for how to write reasonably good code. And there's some static analysis checkers to try to figure out, hey, is this code reasonably well written? Is this code really poorly written? But it doesn't seem like there's very much at the post-compilation level to be able to give an indication either to the end user or to the consumer of a library, is this library that I'm using well written? Like, does it follow the guidelines? Does it have patterns that are typically, vulnerable? And I'm wondering, is there any progress or plan or idea or anything along those lines, either as an end user consumer of software or as a person writing software, consuming libraries, to be able to make a judgment and say, this library is well written and follows good practices, and this library is 10 years old and has copy and pasted C code and does a huge amount of bad things, and maybe I can't find any errors, but maybe I don't want to use this library because no matter how well I write my code, if I'm depending on a library that follows a bunch of bad practices, it's likely to have problems. And I'm wondering if there's any way to do that, or if you see any sort of guidelines for me to better select and encourage products that do follow good procedures.
So one of the things that I talk about, like I talked about this week, is you're only as strong as your weakest third-party library. I prefer libraries that are either open source, that I can go and do my own security audits on them, or I can go and use libraries that have gone through a security audit. Vinny Falco created Beast, which is based on Boostazio, and then one of the first things he did was go out and actually have his library audited by a company that specifically does that. So I have a lot more confidence in his library compared to somebody else. So you do have some market forces there if we begin to say this is what we want. It's not enough, though, just to have it done once, because then every time he makes a change, you need to have those periodic reviews to make sure that you didn't introduce breaking change. There are things out there like Black Duck, which will allow you to go out and find out. They'll sweep through your libraries that you're using and tell you. And one of the things I'd look at is their history. If you're finding libraries out there that are habitually coming up with vulnerabilities, find a better library, because it's not going to get any better unless the company makes a decision that they're going to invest in security.
Right.
Because that really does become the hole in your software. You can do everything perfect, and that one library has the vulnerability, like OpenSSL. There are still people who are using the OpenSSL that has the Heartbleed vulnerability in it, because they just, we'll update next time, and then next time just doesn't ever happen. So it is a significant problem, but I don't know that there is a structured way that we can enforce that across the industry.
Okay, I would like to bring up survivalship bias in this case. A good example of survival, I'm not going to tell the whole story, but there were some warplanes coming back from war, and they were trying to figure out where they had been hit, and deciding that they would armor those planes where they had been hit. They decided, but the thing is, those bullet holes, they survived those, right? It was the places that they weren't hit, which was the actual vulnerable parts. And so my point is here that you be very careful about what you're measuring, right? Some libraries and some products, like browsers or OpenSSL, are targets for a lot of analysis. So you will also find higher numbers of vulnerabilities that are reported because they're interesting, or like in Windows, because it's an interesting target to analyze. But most likely, in my opinion, they are probably the most safe because they have all of the scrutiny, right? So counting how many vulnerabilities reported against a library is generally doesn't really tell you much about how secure it is. Because if you're using something nobody else uses, then it probably has tons of vulnerabilities.
And yeah, I guess that I agree with what's been said so far. The other bit I would add is that there are some tools out there that will try to see if binaries or source code, like one was mentioned, are opting in or leveraging various security features. Like there's BinSkim, which is a Microsoft tool to say, hey, are you using all these binary security features or not? That's only going to go so far, though, right? But at least gives you that kind of baseline for looking at things. Yeah, that's basically what I would say. Yeah,
I mean, I'm much more curious, just to quick follow up on, like, is there any way to tell if they use good practices in source control? I realize we can fuzz things, we can test things, we can do binary analysis, we can check flags, ALSR, that sort of stuff.
Right.
But what I'm really interested in is, do the developers who write this have good practices that are indicative that they understand security, or are they just throwing code at the wall and hoping people use it?
Yeah, and that, I mean, the other thing I would add on to that is one of the ways so for instance, if you are taking a dependency on an open source library and you're actually building it on your side, then one of the ways to impose or control for that is if you have your own best practices and standards that you can actually enable and enforce for those code bases, that's going to be your best bet for actually ensuring that that happens, right? Not always going to be possible or practical, but that's the most control I think you're going to be able to exert other than going and actually understanding the code.
Okay, I have 2 extra points. Okay, now Google has a service, and I don't remember exactly what it's called, but you can opt into it with your GitHub projects, where they will do fuzzing continuously. What was it called?
OSS Fuzz.
OSS Fuzz. And they will do continuous fuzzing on check-in, so you can have continuously checked. And I had another one, but it just escaped me. Okay, I'll come up with it. Several applications that have used like a third-party component that is very important to them will write a wrapper around it and a test suite around that library. And so when they take in a new version, they will run a complete their own personal regression test suite against this. And you can then also write like a fuzzing wrapper around it. And so, because you need to update, right? That's the problem with this. If you do once audit, but there's a security vulnerability in it, then you have to take it in anyway. So you have to have some kind of way of continuously doing this, and hopefully in as automated fashion as you can, because if you don't, then you're not going to do it.
So I think there's a bit of a difference. So when I talk about how many vulnerabilities are in a library, I'm not talking about Windows and I'm not talking about browsers, because those are massive attack surfaces. And they are under siege all day, every day. And so I would expect that the more bugs you find and you pull out of that, and the more vulnerabilities you pull out, the stronger it gets. I'm more talking about the libraries. So there's really 3 libraries. There's the free libraries that you pick up off of the internet that somebody has written. You should be able to go and have a conversation with them if you just have to have that library. Then there's open source, where now you have the source code. You can go look. How are they writing their software? Look at their check-ins. Are they responsive? Look at the comments that are being made. Hey, we found this bug. What's the cycle time on them fixing bugs in their own library? So I'm talking more about third-party libraries I use in my product. And then the third is commercial. If you're selling a library, I expect you to be out there having it continually tested professionally, not your own guys. We are very bad at testing of doing code reviews on our own code and testing our own code. You should be, if you're selling a professional library and people are paying money for it, you should be having that continually tested by a security company or somebody who is trained to look for these kinds of vulnerabilities. So my thing is more the libraries I use, the third-party libraries I use, versus it doesn't bother me that Microsoft has high bug counts. I would expect it. It's a massive operating system, and even browsers, just because they are huge, huge targets because of the position where they are.
We have another question. Ben, hey, how you doing?
All right. So I'm going to put my game programmer hat on and ask maybe a controversial question. If I'm writing just a game or a desktop application, how concerned should I really be about security? Because isn't it the case that if I try and make my code secure, it might impact my performance? I don't want to have to deal with that. So how concerned should I be?
I don't think it's necessarily true, but from it's okay. So Call of Duty. So that is a desktop game, but you're connected up to an upstream server and you're playing with people all over the world. You should be really concerned about security, because I keep hearing about people who've made a really lucrative living about gaming the system and getting things out of the game and selling them on the internet, and that's how they make their money. That tells me that that's an insecure system. If you can penetrate that desktop and get to the upstream server, you're now in a position to jump off into the other desktops of people who have it within their environment. So if it's just your own private game, great. But if it's something where you're connected to an upstream server and connected to thousands or millions of other people at the same time, you should be very concerned about it.
Yeah, and I mean, just ultimately it comes down to what's your threat model, right? What threats are you actually concerned about with your application? In this type of game scenario where you're connected to other people on the internet that you probably don't trust, then it sounds like you have attack surface to me. Same way, if you have a monetary system that you've developed on top of this game that people can leverage in a way that they can get monetary gain through that, that's another threat that you're going to have to deal with. So it's what your threat model is. And I think a gaming scenario is one that actually does have an attack surface that you should be worried about for your users at the end of the day.
Yeah, and that's actually my point. Your users, you care about them, right? And a game is often a binary that you install on the user's machine that is connected by network to somewhere, which makes it very similar to a browser. And you have a close relationship to your users and care about their personal information and their personal safety. And that becomes now your concern because you are the foot in the door, right? So, yeah.
All right, CB?
Hello, yes. So I guess trying to bring us back a little bit to the language, I was kind of thinking, what, in the panel's experience, how much is the language really to blame? And I ask because I'm an occasional contributor to Git, which was written in C. Now, C is a language that's not kind of renowned for safety or security. And Git's had a few security issues reported against it over the last few years. And all of the big ones have been caused by, I think, what I would class as more logic errors. So we take a URL from here and then we pass it into the curl library. Hey guys, did you know you can do this with the URL? And it's like, oh my gosh, yes, we need to be more careful about what's actually in this URL, and it becomes a logic area. And kind of building on that, it's kind of like, so if we can't blame language, and you've talked a bit about auditing libraries, there's another kind of class of security problems where you take a secure thing and another secure thing, and you put them in a way together in a way that turns out to be insecure, in a way that the individual pieces were. And it's almost like as you go from small to big, it seems your chances of introducing insecurity, even though that the pieces are secure in and of themselves, gets larger and larger. So yeah, how on earth do you deal with it as the problem gets bigger, I guess?
Oh wow, I have several things here. Okay, first of all, Git was written by some of the best C programmers in the entire world, right? and I think that is a very important thing, both for C and for C++. It's sort of like you want your surgeon to use a scalpel, but scalpels are dangerous. It's not that you don't want necessarily your taxi driver to be waving a scalpel around, but it's not the same thing, right? So I think C is a beautiful language, and it can be written elegantly, and so there's nothing wrong with C as a language, but it is like several mentioned, it's easy to do it badly, and so it's not a good language for people who are not good at it. And that is the problem, right? You have the intermediate period while you're bad at it, while you're getting good at it. Okay, but the other point that you have of secure individual components being connected and therefore introducing things that are insecure, yes, it's been a thing since Man in the Middle, right? That is one of the places where people try to insert themselves between two things and trying to see if I can manipulate it at that point.
Yeah, I think my perspective on this one would be going back to the notion of, is the language to blame, and if so, how much? For me, I do like C++, but the language is the original sin, right? It's what defined the constraints and how permissive it is in terms of what is going to be possible to get wrong. And as a consequence of that, you're absolutely right. If you're a good dev and you're not going to get it wrong, then you're great and the language is fine. But for everybody else who has to keep all those rules in their head, and even when you're really good, sometimes you forget things, then you have bugs. And so just like speaking from the, like on the Microsoft perspective, you mentioned logic bugs and things like that, which are going to arise pretty much in any language, right? But at least for Microsoft, our experience has been, about year over year, about 75% of the like vulnerabilities that we fix in our like products are memory safety. They're the memory safety flaws that are a consequence of what's permitted by the language. And that's why I come back to the language is the original sin.
So I had a couple things. There was a talk earlier this week about memory tagging, which I think is something that helps every language, but specifically it helps C++ in dealing with some of the security vulnerabilities speaking there. My biggest thing, and one of the things I talk to most people about, and I kept bringing it over and over again when I talked on Monday, is complexity is the enemy. If you've ever studied metallurgy or how planes crash, one thing we understand is that metal under stress, the energy will collect around the weakest point. The vulnerabilities that we put into our systems are going to collect in the areas of complexity. And it's not that they're moving, it's just that we are seeing in the simpler pieces the vulnerabilities, getting rid of them, but the complexity obscures the vulnerabilities that are there. I love C++. I've used it for almost 30 years. I'm not really willing to give up the power that it gives me. And I had to make a decision a long time ago. Either you're going to give up the power and go to Java, which has its own problems, or you're going to learn how to do it correctly. Learn, what are the patterns of the mistakes that you make, that you put mistakes into code that people can exploit.
Cool, thank you.
Next, please introduce yourself too.
Connor Walsh. I was wondering if you have any comments on the propensity of the industry and the consumers that we sell to rely on security techniques that are actually quite aging. I'm thinking particularly of public key infrastructure on which TLS, SSL, HTTPS, all that wonderful stuff relies. Ultimately, that comes down to, can you trust the root certificate authority to which the certificate is chained? Go back 15, 20 years, there was only a couple of certificate authorities. Now there are literally hundreds of them. And if somebody gives you a certificate and it's chained to a trusted CA, how much value does that actually provide you in reality?
You want to take? I mean, this one for me it's a little bit outside of the realm for me, but ultimately, I don't think that so much is a problem with PKI. It's just perhaps a challenge that we face with respect to how do we, allow for pervasive cryptography across the internet in a way that is low friction for the end user. And I think we've been getting better about that, but I don't think it so much has to do with the software side of the security as it does with the protocols and how we actually ensure rigor and trust in that.
I believe you're pointing out some important issues. I also don't believe that we don't have perfect solutions. But I do believe that what we have today and what we're working towards is better than what we had before. And that, I think, is a big deal because we live in a post-Snowden world. We know that people have actually vacuumed up network traffic and analyzed it and used it against people. And so the more difficult we can make that job for those kinds of people, the better, in my opinion. We can't make it perfect, but we have to try, and we have to not stop trying because they're also not going to stop trying. Because for me, privacy and security of the individual person is something that we, as an industry, we need to continue to work towards protecting. So, yeah.
So every time I talk to a CTO or a CEO, and somebody said this the other day, and I'm going to go ahead and use it, is hope's not a strategy. When you're, I hear CEOs. The one I was thinking about was the CEO of TalkTalk in Britain, who's no longer the CEO. They were hacked 3 times, and their comment was, the bad guys just have to get lucky once. We have to get lucky every time, and it just absolutely drives me nuts when I hear that a CEO say that. Is your job is not to get lucky. If anything, the luck goes the other way. They're the ones that get lucky. It's about intention. It's about design. It's about finding out where your vulnerabilities are and dealing with them. Going back to what Patricia said about the airplanes, you do have to patch where the bullet holes didn't kill somebody, but you can't forget about the places where the future bullet holes are going to come through and kill somebody. So I think our problem is less about relying on technology that maybe isn't a perfect solution, because there is no place called secure. It's always relative. What you're doing is you're raising the bar to where they're going to go someplace else and go hack some other company. So I think it's less about, are we using bad technology? I think it's we're not using the technology that we have, and that's why we get burned.
Okay, just to reiterate one of his points. Everybody has costs, right? Even bad guys have costs. Who the bad guys are, or whether or not they consider themselves bad, is relative. But if you're talking about like governments, right? They also have organizations. They have costs. The more expensive you make it in manpower for them to go after you, that will also factor in on whether or not they're going to, because it has an actual dollar value connected to it. I don't know if that answers your question.
I was just thinking, I wonder if to a certain extent we oversell to consumers in particular, like people who have been trained for 30 years that, if your browser says HTTPS, then it's a secure connection. Well, that's fantastic, but if it's a secure connection, either to not who you thought it was because somebody bodged the certificate, or because their server is really insecure.
Well, now you're getting really close to my other passion here, and that is that we have created a society where there is a very small portion of society who understands how it works. We have digitized the entire world. We have digitized people's realities, but we haven't taught them what that means and how that works. And we have told them that they should trust us, and that is so wrong. We are right now living in a world where a very small portion of the population are literate in their reality, and we are telling the other people that being illiterate in that reality doesn't matter because they should trust us, and that is so wrong. So yes, I agree with you. This is not it's not a good situation. It's not how it should be.
All right, folks, and we got around 15 minutes left, so we're going to try to get to everyone's questions. If we don't, though, please feel free to stop these fine folks here in the hallway and ask them your questions. Kostya, good to see you.
Back to memory safety. We have a few memory safety types of bugs, and one of them is frequently overlooked, uninitialized memory. Meanwhile, it's probably the only one that is easy to fix on the language side, yet no one has done it so far. I've approached many people trying to say, hey, let's just flip the default. Let's do malloc zero fill and stack variable zero fill by default and have an escape hatch. And every time I hear the answer, no, it will cause an unknown small performance degradation. So what is your answer to this? And did you hear other answers from other people? Thank you.
Great question. So it probably won't surprise Kostya that I'm very much aligned with his goal of wanting to be secure by default. Right, and kind of what I've been saying throughout this panel is let's be secure by default. Let's make it so that developers don't have to think to do the right thing, that the right thing just happens, right? And in the scenarios where, wow, this is really perf sensitive and I can't stomach this auto initialization here and I'm going to be really careful about it, then in that case, you take whatever steps to opt out of that. And so I totally agree. I think there is a very clear path from a language and a compiler perspective to eradicate, at least for stack-based local variables and things like that, and globals and whatnot, uninitialized memory. Heaps allocated memory perhaps is a little bit more expensive, but also there are paths there that, if you are willing to embrace this sort of secure by default concept, I think it's a path we should march down.
So we make trade-offs all the time. For performance, we make design trade-offs. We're used to doing that. But the thing I tell them, if you're worried about performance, there is nothing that will crush your performance faster than an exploited vulnerability. So you have to choose. One of the places, like for example, where you can trade off, where you don't have to make a trade-off you think you do, is if you're validating data coming in past a trust boundary, and you know you're in a position to where that you don't have to validate that data at every single step, that you will take a performance hit on. So I don't think it's, and I loved your talk, by the way. Kostya did the talk this week on memory tagging, which I thought was fantastic. I'd love to see that built into the hardware. There's a lot of things we can do deeper down, which means we don't take the performance hit on our applications. But I don't think that I don't think every time people will bring up performance as that's the reason why I don't want to do this. You find out it's really not a performance problem. It's a perception of a performance problem.
I'm good.
Moving on to Gaspar again.
All right, so one thing that I would really like to see on GitHub a lot more is one more file with all capital letter names, which would say SLA. And I am totally understanding that most GitHub projects are going to say none, and that's fine as long as they say it and they think about it. And I was really also fascinated by the book Nudge, and I really like all the badges that GitHub gives you. So I want to ask you, what are your favorite non-existent GitHub badges?
Oh, Jesus.
I don't even know what the GitHub badges are that we have, so I can't tell you what's not there.
Like the SLA badge would be one, for instance, for me, but do you have other?
Well, you could do bug turnaround as part of an SLA. You know, how fast people are, how responsive they are to actually doing those kind of actually turning the bug around. The other thing is going out and having audits. How often is your code audited by somebody who is not you? Because we have a tendency to, oh, they're playing some nice music next door. We overlook our own bugs. That's why, you know, if you have a bug bounty hunting program that's inside your company, it's good to have somebody else go and try and penetrate your code, because we're really bad at testing our own code. So those would be kind of a couple things.
I feel we're being very unfair to open source projects, because they are working in general for free, and we are using their software for multi-million-dollar businesses, and we're not paying them. So then rating them on the quality of their work, I feel is really unfair in the way that they are doing it in their evenings and in their spare time. What we should do is, if we really take it seriously, and I think we should create models that actually pay open source developers so they can spend time on their projects. And I think that would be helpful for the entire industry.
Yeah, very little to add on, but I mean, I agree with that. I also would say that it kind of comes back to what you said, where it ends up being ideally what you want to see, whether it's in an open source library or any product that you're looking at, what the level of maturity is, and sort of the notion of the security development lifecycle and their ability to respond. Like, those are the two indicators that you're looking for, and there might be different badges in there, but you know, for just your average open source library that has 2 people working on it, there's only a certain amount that you can expect from that, right? You don't have to do it. Yep. Show that you're not, and that's fine. Like, just own up, own it. Sure.
So the thing I like about open source, I like it for 2 reasons. I like it as a developer because I've got the source code, and I go, look, I like it when I'm penetrating a system because I got the source code and I can go find the vulnerabilities. Some of the worst libraries I have ever worked with were not open source. Some of the best libraries I've worked with were open source. So I don't think this is a problem, open source versus commercial, because you can have some absolutely dreadful commercial libraries that when you finally do find out how easy it is to penetrate them, you will go look for an open source variant, and then just having a conversation with the other thing is, if you're getting an open source library and you want to use it, offer to do the security review for them. There's no reason why, if you've got that special skill and you know what to look for, there's absolutely no reason. And most open source library authors will say, yeah, absolutely, please let me know where they are. Go fuzz test it. Go do the kinds of things you would do on your own software, do it on open source, and then give them the information so they can fix it in their next release.
All right, so we've got a last security review at badge. I like that one. We've got a continuous fuzzing badge. I think I heard something akin to that.
Is there a gold star you tried badge for when you get like a certain threshold of bug reports or something?
I'm down.
Okay, we should get to that.
Okay, moving on. Ben.
So I'm a C++ programmer. I can learn how the STL works, how the language works. I can learn the language of design patterns. I can learn good coding practices and be able to give a code review. But if I were to look at a library, I wouldn't know where to start about a security review. How can I develop the skills to give a security-focused code review? What are the patterns that exist?
Okay, number one on the top of my list is where are you moving or copying memory? And I'm not talking about standard move. I'm talking about if you're using string copy, string end copy, mem copy. Heartbleed was a mem copy problem. Where are you moving memory? Because you're likely to get that wrong, especially if you're using pointers and offsets. Are you verifying the sizes of the buffer you're coming from to the buffer you're going to? Where are you consuming information from an untrusted source? We have this concept. It used to be that we sort of believed, okay, everything on the outside was untrusted and everything on the inside is trusted. We've given up on that. Everything is untrusted. So if you have an IPC connection that is taking data from somebody and you're not validating the data and you're not verifying who's sending it to you, that is an easy thing for me to exploit. And for almost everybody in here has multiple processes that have to talk to each other. So there's two right there that are very simple. I covered a bunch more. So if you want to learn the places where I go, I actually had 2 slides on it, which is these are the things that I go and I look for. It doesn't, in the same way that we understand design patterns, because of Gamma's book, we also have patterns of vulnerabilities in the same kind. We repeat the same mistakes over and over and over again. So there are 2 slides on there. If you just start with those slides, validating and verification is an enormous, you're cutting out entire classes worth of vulnerabilities when you just do those 2 things.
Yeah, I don't have a lot to add on. I think that was a great answer, but ultimately at the meta level, it's understand the attack surface of what you're reviewing, right? Understand, like what's untrusted, how you're handling validation, and the coding patterns that give rise to vulnerabilities. Like building up that base of understanding will put you in a position to audit with a security mindset. But the people who do this professionally for a living have developed a lot of intuition and skills for looking for specific patterns of vulnerabilities. That just takes time, but those are kind of the meat and potatoes for where you can start.
Okay, I love to plug my own talks. So you see the video of my talk from yesterday. It's a good start. But no, I think this is a very important problem, actually. We have today very little security in software development education. And that is a big problem. And also we are not measured on security. We're measured on throughput and quality, but we're not measured on security. And that is something that I'm hoping to work on more, trying to make materials, especially for the C++ community, to change that. But just from my talk yesterday, I had my 8 I'd really rather you didn't. And the first one was I'd really rather you didn't use C. And I told you earlier, I love C. There's nothing wrong with C. But if you're in C++ and you're using C, especially for string manipulations and things like that, that is like hot potato territory. And I held a version of that talk, a little less technical, like 9 months ago. And a security researcher came to me a few months ago, and he said, after seeing your talk, I've been looking at vulnerabilities that are coming in, and I realized that you're right. Like the code that I'm seeing from C++ programs and the snippets of code where it was vulnerable, it's always C. So what I'm saying is that a lot of the developments in C++ for the past 10 years have been to address those areas. And many of the things that are security issues are things that we have traditionally thought of as bugs, like double free, like casting something to something it's not, like not deleting things. But especially what you see is a lot of the string stuff. Car star is If I'm in a code review and I see somebody using CarStar, I'm like, okay, wait, excuse me, or give me like, okay, I'm gonna. So you have what we need is a culture where we get to like a code smell feeling. Like you look at something, it's like, oh no, my spidey sense is tingling, right? So that's where I hope that we can get. But for us that didn't have it at school, it means we have to kind of do it consciously. But also, I think we should bring it more into schooling.
Less than 5 minutes to go. I think we can squeeze Bryce's question in.
You talked about libraries and response and not being able to control the libraries that you bring in all the time. To people who might do vulnerability research, can you talk to disclosure and how that would be? I know there's a lot of controversy about like how it should be handled. I'm sure as someone taking in vulnerabilities, you want to wait for, oh, give us time to fix it. But say you've got a library that a lot of people use that they're not responsive. How should vulnerability researchers handle that disclosure?
This is a very good question. I think that today vulnerability researchers have, in my experience for the past 13 years, are very, very responsible people, ridiculously responsible people, and and they will go out of their way 15 times before Saturday to try to tell these people what is going on. So what we need to work on is more on the other side of being responsive, of being transparent, of being grateful for this work that has been done for you for free. And we are not good at that. We are defensive, we are aggressive, and we are unresponsive. And so definitely, I don't think that there is much more that security researchers can do. I think they've done a really good job at both acting responsibly and also about creating routines around this. But I do think the industry needs to change, and we need to be better at receiving vulnerability reports and handling the media event that happens around that in a good way. Did that answer your question?
Yes.
Okay.
I mean, the one thing I would add on is that if you are a security researcher who's found a vulnerability in a library that's used pervasively by a number of applications, and they're not being responsive to your reports of vulnerability, your other tact is to go to the vendors that are using that library and say, hey, you know you have a vulnerability. And chances are, if the library developer doesn't care about it, the people that are using it are going to care, right? And they will either work with the library developer to get it fixed, or go and manage it themselves. So that's one tact that you can use rather than, hey, they're not responding to me, I'm just going to drop a 0 day and go on with my life. That's one way to do it. But I agree with her comments too, that we want to be good to researchers and want to help give them positive, give them the recognition that they deserve for helping to make things more secure. But if that's a specific case you run into, that's one tactic you could use. Yeah.
So I'm sort of in the tough love camp, which is I find something. That's why I love bug bounty programs, because they reward people for finding things like that. But if you don't have that, you give them a certain amount of time to get their act together, get the vulnerability fixed, and a patch out. And then after that, it's on their head. The thing that bothers me the most is not the 0 days that I as a researcher might find. It's the 0 days that governments are finding, and then they save them back for a rainy day. The problem is it always seems to be raining. And then it winds up out in the wild. The vendor doesn't know about it. Microsoft, I know, has been victimized by this more than once. Linux has been victimized. That's, I think, the problem where we have governments, including my own, that are behaving irresponsibly because they're trying to get a competitive edge. It'd be one thing if you use these things and you kept containment, but they don't. And they get it out into the wild, they're weaponized, and then the weapons all get turned on us. So I think for vendors that don't want to be responsive, okay, you get 30 days and then it's in the wild, and I like the idea. I don't know if you can notify all the vendors or even know all the vendors, but I like that idea. You give them a certain amount of time, but I think the bigger problem is just that we have an arms race now, and it's not nuclear weapons. It's all vulnerabilities in operating systems, browsers, and software that
people want to use to be able to get a competitive advantage. And that, I think, is where we're getting the huge amount of 0 days that are showing up.
Maybe it's like, a comment to that is like, I would recommend also getting a CVE number. Basically, the Mitre is adding a lot of information into databases, and for example, Linux distributions are scanning all their packages against that. So the maintainers of the distributions like Debian and Red Hat will then also contact the library authors. And if it gets really worse, the computer emergency response teams, like lots of universities have them, will actually also look at that. Additionally, lots of like CVE scanners are out there, and suddenly like people or customers actually might run them, and suddenly like something flags up as, oh, this is a CVE. So customers suddenly also could make pressure on that.
This is not my expertise necessarily, but I believe it's not always that easy to get a CVE number, though.
So if you want to do that, there's openwall.org, where you can just go to the website, and it's just like one email, and they reply normally within 24 hours with a CVE number, and they actually fill out, like if you give them enough information, they actually fill out even the CVSS, the scorings for you, so you don't even have to do anything.
Awesome.
So it really works extremely easy.
Repeat the URL.
Just Google or like search for OpenWall.
Openwall.org.
Okay. All right, folks, we are actually out of time. Thank you very much for coming to our security panel. Thank you very much to our panelists.